explorations, and new AI-based services at DG Translation. To start, yes. Now you can see the second slide. Yes. To start with the global picture, AI is of strategic importance to support efficiency, effectiveness, fairness, and the speed in the decision-making process at the Commission. One of the priorities of our Commission is that Europe fits for digital age. And AI takes an important role in this priority of the Commission. And the Commission itself is leading by example to reach the next step of the digitalization with systematic and structured approach towards to AI. AI in the Commission is actually not new. E-translation started 6 years ago, and it is the flagship AI project in the Commission. This is the result of a fruitful partnership between DGT and DG Connect in the framework of the Connecting Europe Facility and Digital Europe. To the e-translation platform, EU officials have access to, but also EU public administrations, universities, SMEs, NGOs in Europe, but also in Iceland, Norway, and Ukraine. In recent years, the e-translation project has added more services, including speech-to-text transcription and other services for natural language processing. In 2021, here in DGT, we gathered approximately 40 ideas for new AI explorations. And still in 2021, we launched a number of new explorations on potential new AI use cases. Some of these were DGT specific, some others with broader relevance. The most wanted application in DGT was the Semantic Similarity app, which is an application that detects semantically similar documents. I will go into detail about this project. My colleague Borislav, he will go into details on the term extraction exploration. As for summarization, initially it was an idea for a potential new AI use case. Then it became an exploration. And finally, today, the summarization service is a new AI-based full-fledged service. As regards assisted editing, this project was presented in the morning, and this is an exploration which could help authors in other DGs when they work on the originals and before they send their documents for translation or for human editing. Evaluation sampling is an exploration which could help DGT to evaluate freelance translation. And there is also an exploration which could warn about quality issues in a document. Coming back to eSummary, which is the summarization service, eSummary, just like eTranslation, is available for the EU staff, for national public administrations, academia, civil societies, and also to SMEs. When it comes to summarization within AI, we have different models. There is a model which extracts sentences from the input text, but there is another type of model which generates new text. This e-summary service, which is available via the address that you can see on the bottom of the page, this e-summary service is generating new text. So it is the model which uses the abstractive summarization to generate new text. A few words about the AI at EC network. The AI at EC network is a community of both business users and technical experts who are focusing on practical and concrete use cases for new AI technology at the Commission. DigiTranslation has the mandate to build and to lead the AI at EC network as the Commission's official corporate AI network. This we do in close cooperation with the Directorate General for Informatics, DIGIT, in charge of informatics, and with the support of other DGs such like GRC, HR, SecGen, and the Publications Office. Currently, we have more than 2,000 participants for more than 60 different entities from different DGs, agencies, and other institutions. The concept of the AI at EC network is based on three main action strands. First, we try to identify AI opportunities and use cases. Then the ultimate goal is to facilitate the exploration and to contribute to new AI projects and services. And more generally, the aim is to build and to share business knowledge in the field of AI. And now I'm coming to the semantic similarity application, which is already in use in DGT. So this application detects semantically similar documents. The scenario in DGT is that there is a new incoming document, and the documents that arrive at the same time, documents that are already in the workflow system, and documents that have been recently finalized are compared to this new incoming document. The result of this comparison is a ranked list of highly similar documents, and the ranked list also indicates the similarity expressed in percentage. And what is the AI behind this application? The semantic similarity tool uses a sentence transformers library and a pre-trained transformer model to generate sentence embeddings. Sentence embeddings are numerical representations or vectors that try to capture the meaning of a sentence. Each sentence is represented by a series of 384 numbers, 384 numbers, regardless of the length of the sentence and regardless the language the sentence is written in. The vectors represent the position of a sentence inside a virtual semantic space. The position of the sentence in the semantic virtual space depends on the meaning of the text. Sentences that are close to each other have sentences that have similar meanings are close to each other within the semantic space. The application for semantic similarity stores such sentence embeddings in a special vector database. That vector database runs searches to find similar sentences based on the distance between their position. Both the sentence embedding process and the semantic search are heavy processes that require GPU power. To sentence pairs, to sentences, so-called similarity scores are attributed. We distinguish between identical sentences, very similar sentences, and similar sentences. The similarity score goes from 0 to 1. The similarity score 1 is attributed to identical segments, and if two sentences are not similar at all, then the similarity score goes down to 0. Identical segments have the similarity score between 0.999 and 1. Very similar segments have the similarity score between 0.799 and 0.998. And similar segments have the similarity score between 0.599 and 0.798. If you take a look at the examples, in the very similar segment example, you can see that part of the sentences are identical. There is a part which is not identical, nevertheless similar. So a very high similarity score was attributed to this segment pair. If we take a look at the first example of the similar segment, when such a manual verification is completed, the authorities turn a yellow link into another color. In other words, a yellow link indicates that a manual verification has not yet taken place. So you can see that the meaning is similar. So the semantic similarity is captured by the tool, and a similarity score of 0.72 was attributed to these similar segment pairs. This was an example of a monolingual semantic similarity, but we can use the semantic similarity tool also for multilingual semantic similarity. Let's take a look at two examples. Italy in Hungarian is Olaszország. You can see that a very high similarity score was attributed. If we change only two letters and instead of Olaszország we say Oroszország, which means Russia, you can see that the similarity score dropped significantly. If you take a look at the Spanish example, you can see that only two letters were eliminated. No, no, which is the negation. But if we eliminate the negation, then the sentence gets a different meaning. And you can see here as well that the semantic similarity score dropped significantly when the negation was dropped and the meaning of the sentence changed significantly. Within DGT, we receive similarity reports, but we can also follow a semantic similarity report, which is generated every day at 8 o'clock and which is updated every 2 hours during the day with the new incoming documents. But units with DGT receive also semantic similarity reports, which are tailored for the unit. On this screen, you can see an example from the Croatian unit. We have Croatian Unit 1 and Croatian Unit 2. What can you read from the semantic similarity report? You can see that COM 2023 002550002 document from DGCOM arrived on the 6th of June in English, and it has to be translated into all languages. You can also see the length of the document expressed in segments and also in words. Then underneath, you can see a ranked list of similar documents. The ranked list of similar documents contains documents from DGCOM, but also from other DGs like from DGHR or DG Agri or DG Connect. What is highlighted in red are those DGs which are in the portfolio of the other Croatian unit. You can also see when those documents enter the workflow system, and if the word sent is not next to the highly similar document, it means that those documents are still ongoing in the workflow system. If sent appears next to the highly similar document, it means that the unit has already finished the translation of those documents. This report contains only those files that are relevant for the Croatian unit. After the pilot phase of the semantic similarity project, we launched a survey. And during the survey, we also gathered some testimonials which indicated the usefulness of this tool. For example, one unit received a new document, and thanks to the similarity tool, they discovered that that document was 99% similar to another document. And they kept in-house instead of outsourcing that document. Another example, an identical document, so one and the same document arrived with 3 days of interval, and thanks to this similarity tool, it was discovered that the document is identical, so no need for that translation. And another testimonials indicated that they received a package of 7 documents. Thanks to the tool, they can identify which documents they should translate first, or which they should outsource, and the rest of the documents can be translated on the basis of those 2 documents. And with this, I give the floor to my colleague Borislav, who will give you an insight into Termit1, the term extraction project. And I will look into the questions if you have any, and I will get back to you at the end of the presentation.
Thank you very much, Bettina. Maybe you stop sharing, please, so I'll start.
Sorry.
Okay. Okay, let me see. Okay, share. Let me, sorry for this, I just
Okay, we can see your slides now, Borislav. But you are a bit frozen.
We can also see the laser pointer moving, but we cannot hear you.
Can you please try to restart your camera, Borislav? Apologies for the technical disruption here. Okay, let's see. Borislav, we can see you moving with your slides, but we cannot see your camera. Maybe try to leave the meeting, come back. There are only 65 people, so you should be able to join again, and it should fix the problem. Okay, while we are waiting, please, everyone, you can use the opportunity to ask Bettina something. If no one is asking in the meantime, I have some questions I can ask myself. So Bettina, my first question to you would be if you've learned something unexpected from doing the pilot project.
Whether I learned something unexpected. In fact, we were concentrating rather on how to build and how to make this project more user friendly. I am not a developer, so I didn't do anything in the development. I was testing the project, and we were rather looking into how we can make it more user friendly and useful for the translation units.
Okay. Then the second one would be, do you think that the semantic similarity could be more useful for evaluating output of machine translation tools than, for example, test scores?
Exactly. That could be useful using the multilingual semantic similarity. It could also be useful to warn on quality. So absolutely, it could be further developed in that direction. And I can see that Borislav is back
I
with
can
us.
see him too, so I'm gonna pin Borislav. Let's see, try to start your presentation, please.
Yes. Let's see if I can share now.
So thank you, Bettina, very much for taking the few questions now.
Okay, share, and then share. And then I hope you're able to see something.
Well,
is it okay, Lucas?
We can see the presentation and we can see you now. Let's go.
Okay, perfect. Thank you very much. So, good evening, everybody. I'm really happy to be here and to be able to speak about our tool developed in the Commission, Termite 1, which is used for term extraction. So, let's see first some use cases which we can have in DGT. So, for example, for term extraction. So, for example, for a new incoming document for translation, if we extract terms and we create a term list, we can have we can pass this term list terminologist for some proactive work even before translation starts. Then the results of this proactive terminology work could also be saved in IATE to be used and reused. And of course, we can combine AI term extraction tool as Termite one with some commercial tool like Synchroterm. Then if we pass a term list to translators, they can use this term list to see how difficult the document is and what is the topic. So maybe they can decide to contact a national expert even before starting translating. And then they can also create a monolingual term base for Studio or for any CAT tool in order to fill it during translation and ensure in this way terminological consistency throughout the translation. And then we're coming to what we call automatic use, which is actually we can use the term list in order to improve the results for mid-translation, which means for machine translation. We can use also terms as a metadata for documents and also to detect the terminological similarity between different documents. So now let's see what actually why to use AI for term recognition. So as you all know, AI is a fast developing technology with a significant potential. But at the time when we started, maybe even now, it is still a little bit underexplored as far as it concerns term extraction. In the same time, because there were some articles, of course, about term extraction using AI, but only few articles, not too many of them. And then, of course, AI is very powerful because it is able to learn from context, to see what are the relationships between the words in a sentence or text and learn from this. It is very adaptable because what the AI will give as results depends very much on the data we'll provide. So if we provide the right data, the data that suits us, it's very probable that the results will suit us as well. And in the end, we should never forget that it is always necessary to have human evaluation of the results at every time, especially in the beginning, but all the time to be sure that the results are correct. Then let's see how we decide to use AI in our concrete case of term extraction. So the task, we define the task as a supervised sequence labeling. Sequence labeling because we had to label the words in the sentences, which we consider as terms, in order that the model to be able later to, when we provide it with new text, to be able to label the words in the text as terms, the words according to the training data. It's supervised because of exactly the training data, because we provide the training data with already labeled words as terms inside, in order to obtain the best possible results from the model. So when we're talking about AI training, AI models, AI in general, we always need a model and data. The model is okay, long short-term memory model with conditional random field layer. At this time, this was the best possible option for term extraction, but of course now with the generative models, which are very powerful, the discussion is open, but it's really an open discussion to decide whether we prefer to use a generative model or a small, very specialized model like this one for very specific tasks. And what such a specific task is the term extraction, for example. This is the model, and that the data we used, of course, it was the EU legislation. And let's see actually what we have done exactly for the training of the AI models. First of all, we used FLAIR NLP, a very simple framework for state-of-the-art natural language processing. We extracted over 13,000 terms from EU legal documents. These were the terms with definition, because we considered that terms with definitions are the most important terms for a given document. Then we extracted sentences from EU legal documents containing these terms in order to provide the context for the training of the model, because as I said just before, context is very important in the case of AI. And this is just an example of how we prepare the data. For example, here actually we have 3 columns. Each word is on a new column, on a new line, as you can see. The second column is part of the speech tagging, which, by the way, we have done using Spacey and the AI model, which is interesting because it's actually used an AI model to prepare the data for another AI model. And actually, the third column here is the most important. Here we use BioS tagging to tell to the model if a given word is a term or not. For example, here debt management operations we consider to be a term, multiple word term. So we use B term for the first word, beginning of term, I term, inside term, E term, end of term. And then when we had a term which is only one word, we use single term, S term. And all the other words, they are O, which means outside of term. This was the way to tell the model, this is a term, this is not a term. So after the training, the model was supposed to predict in a new text which words are terms, which combination of words are terms, which are not. Then we trained the first model using a subset of 28,000 sentences. We used, by the way, Amazon SageMaker machine with one GPU, just to say it. And then it was quite interesting. The results were quite interesting. We got feedback about the results, and we decided to train a second model. But in this time, we decided to use a smaller subset, only 7,000 sentences, but with a higher frequency of terms. So each sentences had more terms than the sentences used here. And this way, we're coming to the termite one itself, which is term extraction 2, which is based on these two AI models trained in-house for detection of terms. Why the both models? Because actually, as I said, the first model, maybe not, but now I'll say it. The first model extracted terms, and the second model extracted even more terms. So it thanks to the training data we used. And we had some terms in common, but also we had some unique terms detected by the first model, and of course, unique terms detected by the second model. So we decided to combine their power in order to get a longer term list. And then we're using also a third AI model, which is publicly available. It is used for named entities recognition. It is very powerful. It is used also by e-translation natural language processing services. And of course, we added some additional features through traditional programming, including IATE checks, which means that for the different terms, we call IATE to see if the terms are in IATE or not, to get some additional information. We're calculating term frequencies in the text. We are doing acronym extraction, etc. So the access to the prototype, okay. Now we have a prototype. Actually, Termite 1 is just a prototype for the moment. And access to this prototype is done via a web interface. So here you can see the web interface. It's very simple. Anybody can use it immediately, no need of special training. We can provide the internal reference of a document and our email address, or alternatively, we can upload the file. And again, we need to provide our email address. And then we're getting back an email. In this email, okay, here in the body of the email, we have some interesting information, some links. But the most important is the file, the Excel file, which actually contains the results from the term extraction. And then here we can see that in the best case, we have 4 sheets in this Excel file with the results. The first sheet is terms, which means that here we have the terms which are detected by the 2 AI models trained in-house. So the first column, we have the terms, then we have the frequency of the terms in the document. Then we have the detection, which is the number of times when the terms were detected as terms by the models. Some information from IATE, the reference of the entry, if any, if it's primary or not. And then an example, which is a sentence with the term in it. So the end user can see immediately the term used in context. Then definitions. If the document contains terms with definitions, we also extract these terms. So we have the terms, again, frequency, and we have, okay, they're not in IATE here, and we have a definition itself. Then we extract acronyms. Again, frequency, we have the information from IATE, and we even try to guess the possible meaning as good as possible. And the last, for which we use the third publicly available model for named entities recognition. So we have the named entity here, and then the information from IATE. So now I'll present just very briefly some results. Actually, these results were extracted using only the first model, but they're still interesting. Here you see some of our documents, for legislation in this case, and you can see that the terms are quite interesting. Then we tried also the extraction with press releases, and it's okay. Seems to be okay, like foreign subsidy, foreign financial contribution, base year, etc. And now we're coming to something more interesting because, of course, we wanted to try to see how Termite 1 will perform with texts which are not EU legislation, to see what will happen. And so we tried with weather forecasts. So you can see here severe storms, cold front, and rain prospects, which seems good. Then for a pizza recipe, you can see here fresh mozzarella cheese, which is, I think, very important for pizza. Of course, wash bowl also could be important to make a pizza. Then if we try this with washing machine user manual, you have wash cycle, cold water, selected cycle, so seems pertinent. Then horoscopes. For horoscopes, I'm not sure, but still eclipse tunnel, space of clarity. And I really don't want to know what are outer demons, but okay, maybe it's something important in horoscopes. Then, of course, Martin Luther King, I Have a Dream. So white men, colored citizens, and okay, Little Red Riding Hood. Okay, grandmother's bed, big ears, big legs. And then we have the Lewis Carroll Jabberwocky, which is one of the greatest nonsense poems written in English, but actually it is full of English nonsense words and neologism invented by Lewis Carroll. And it was interesting to see that the two were still able to extract some of them, which are looking like terms to me. So that is from me. Thank you very much for your attention, and we'll be happy to answer to your questions.
Thank you very much, Borislav. I'm actually quite disappointed that I saw only 3 terms in the whole of Jabberwocky, but can't have everything. There are still no questions in the Slido, so please, I would like to invite everyone to put them in and not be shy. My first question for you would be about the relevance for our audience. So it's something that Bettina already touched upon. Is Termite 1 something that our colleagues, translators from outside the European Commission can leverage?
For the moment, Termite 1 is available only to the colleagues in the Commission network, because it's a prototype. And once, maybe soon, maybe not, I don't know, it becomes a service, like e-translation, for example, it will be accessible under the same conditions as e-translation.
So the person to best for that would be Christiana, I suppose. Yeah. Okay, my second question would probably also be for you, Borislav. With the 3 models working together, how reliably does Termite 1 recognize terms if you run the same tool on the same document several times? Will you get a lot of false positives or false negatives, something that did appear the first time but not the second?
Actually, this is something very interesting. I thank you very much for this question. It's something very interesting because I spoke about small specialized model and a big generative model. Obviously, a generative model like ChatGPT, you always get somehow different results, slightly different or more different. And with these two, actually, with these models, you're getting always the same results, which seems interesting in some cases, at least to me. We have some repetitivity here and some, it's kind of stable, if I dare say.
Okay. Then for some of the other terminology tools, some of the leading industry tools like Tatra Term, one of the issues was user friendliness. How friendly is Termite 1 to use?
It is extremely friendly. I'm not saying this because I'm so much involved into it, but as I mentioned, you have a very simple interface. You just have to submit one document, even the reference. You don't need to submit the document itself. It's just the reference, and then you have you submit your email address, and you get an Excel file with terms inside. So it could not be more simple, I think.
Okay. Would it make sense, for example, to have an API output that would connect to something like a live term base so that you could connect it at the project creation directly? Oh, sorry. And also for Michal, before you answer, Michal is asking where you can find the Slido. If you put sly.do and put the code TEF7, you should be able to get where you need to. Sorry, Borislav?
No problem. Thank you. So yes, actually, it could be used in a very automatic way. If you submit document to it somehow, you get the results automatically. So yes, can be connected to the I mean, could be used during the creation of a project. I mean, no problem.
Okay, that's good to know. Then my next question, that would be probably for Bettina. I hope that she's still in the chat with us and in the talk. And that would be about the other use cases for the semantic analysis beyond what we are doing now. So we are doing similarity reports to make it easier for translators to get the correct documents together at the same time. Did you find any other use cases that you didn't expect?
Other use cases that we didn't expect. Um, just to give you more context about the semantic similarity tool, because it is sometimes misleading what the semantic similarity tool gives compared to the match rate. So let's start with this. Match rate, what is match rate? It is the percentage of already translated documents that can be retrieved from the central memory. And the semantic similarity tool is a complementary tool which analyzes documents not yet translated, which enter the workflow at the same time, or which are still ongoing, where we still do not have the match rate, or documents that have been recently finalized. I don't know if you are still here, Lukas, or we simply
Yes,
lost.
yeah, I'm still here. I'm listening.
Okay. That is the main purpose of the semantic similarity tool. So it is a complementary tool to the match rate. And other use cases can indeed be related with the multilingual semantic similarity that could warn about quality issues. If we extract only the similarity, the similarity segment pairs, that would extract the right terminology, perhaps. So it could also be used for terminology extraction or quality warning. So there can be other use cases built on this use case.
Okay, thank you very much. There is a first question now from Michael on Slido. So how fast is this tool? Could I use it as an interpreter in the booth? I suppose this one is for Borislav.
So for the moment, we are not sure because we're using it on a machine with one GPU, and it shares this machine with other prototypes. So the fastest was like 10 to 20 seconds, but if you have a dedicated machine with maybe more than one GPU, it could be even faster, I think. I'm not sure for real time if it's possible or not. It should be tested.
I see. Maybe, Michael, if you are here with us, I see that you are. If you can unmute, can you specify a bit more your question? And then how would you want to use the tool in a booth as interpreter? Sorry, you are still muted. Sorry.
Maybe you need to change the mic device.
Yeah, you are not muted by the platform, but something's not working.
Sorry, I muted myself. Sorry.
Perfect.
So I will repeat it. My name is Michael Mietke. I'm based in Maastricht, and I work as conference interpreter since 1990. I I'm a member of Tech for Word, and maybe you know this organization. They they are teaching us a lot of technology development. And what's the critical stuff for interpreters is how many apps or devices are in between the input and the output, because this makes the time lapse between what I hear, the speaker, and then the machine presents the let's say the terminology. And we are interested in dates, in names, and terminology during interpreting.
Okay, if I can add in this case, actually, it's you have separated sentences, if I understand well, which is good because this tool is able to actually treating sentences one by one, which means it's very fast. When it's only one sentence, it's really fast. So I would say that it could be possible, but okay, we need to test more to see if it's possible. We have never tried to use it this way because I'm sorry, we are in the written translation, so that's more about written text.
What we see at the moment with, let's say, a digital booth, you get always when you put the terminology in advance into the program, into the app, then you have a time lapse for about 1 second. But then I have to I already put the for this interpreting session, I have to put the terminology in advance into the device. So it's different than what you are doing, because this would be new, and otherwise I already have my text, my documents, and I prepared them and put the names, dates, and so on in it, and it recognizes these features when they are spoken. So when it said Angela Merkel, it recognizes because I put Angela Merkel in advance into the device, and it takes about 1 second to show it.
Okay, it's okay. Just one more point. If you have some texts which you want to use for the preparation, you can use this tool to extract terms from these texts. Actually, before.
Good.
Maybe not real time. I don't think real time could be used, but maybe before you can use it to extract terms.
Okay, good. Thank you.
Thank you for the question and for the answer, Borislav. We have one more question and about 3 more minutes to go, so we definitely have time for this. Do you get the translation of the terms in the list as well?
Thank you for this question, because it's a very interesting question, and it's actually I am getting it quite often, which means that there's interest for this. There's two options actually. The first one is to get equivalents from IATE for the terms which are already in IATE. We saw that some of them we have number of the entry in IATE. For these ones, it is possible to get, or it will be possible. We need to do a little development, but it's not very difficult. We can get the equivalent in a given language, which you precise in advance, of course. Now, if we want to do this for terms which are not in IATE, we obviously have to submit how to say it? I mean, the original with the translation. I mean, we need the two texts together in order to be able to extract the equivalent of the term in the source language, the equivalent from the target language, and we don't have this yet. I mean, for sure, this is not developed yet.
If I may just put a small wrench into this, now if the term is already recognized in IATE and has a translation there, is there an additional benefit in having it recognized by Termite as well? Because I already have the IATE term recognition, right? So.
Exactly, but actually we're working together with, we are in contact with the colleagues who work in IATE, and who actually will use all these tools together. Ultimately, this is our goal, to get the best possible result. So yeah.
Okay, well, that
we
does
work
make sense.
We work together with them. Yeah, absolutely.
Can I also add something to this? For example, when a new document enters the workflow system, the terms could also be indicated somewhere, which is not the case if we use IATE. So when we when the document enters the workflow system, there could be a button or a tab that shows the terms. This could allow the workflow managers to assign the task to a translator who is familiar with that area. So it could be useful even before entering IATE.
Okay, that makes a lot of sense. Thank you very much, Bettina and Borislav both. Our time is now up. So I thank you very much for your presentation. I thank the audience for your questions, and I'm looking forward to see you tomorrow.